My name is Jackie Whitehead, and my research project at CLU is the dye-sensitized solar cell. So what a dye-sensitized solar cell basically is we take berry juice or other organic materials, use the sun, and make electricity. So if you want to come on over here, I'll show you a little bit of my project. So what I do is I take glass slides like this that are coated in tin and they're conductive, and then I put titanium dioxide on them, and the titanium dioxide then soaks in various berry juices. So here we have blackberry juice, and it comes out looking like this nice deep purple. Very nice. And then you take another tin coated conductive slide and you put it on top. Use binder clips to put them together, and then you activate it with the electrolyte, which is iodine and triiodine. And we'll do a test and show you how it works a little later. So here we are in the OChem lab that Dr. Shinachi lets us use and work on our projects here, which is really nice of him. So we'll go back into the chemical storeroom where we get a lot of our chemicals that we use for our projects. I use this a lot. This is the acid corrosive cabinet. And over here is the fridge where I store some of my samples. So right here is the blueberry juice that I made yesterday. And here's the blackberry juice that I made 2 weeks ago. And there's Dr. Tanachi. So now we're going to put together the dye-sensitized solar cell and test it so we can see how it works. So what I'm going to do is I'm going to take the slide that's coated with the titanium dioxide that's been soaked in berry juice and put the counter electrode, which has a thin layer of carbon on it, which acts as a catalyst, on top. And then I use binder clips to attach them. And then the electrolyte, which is iodine and triiodine, which will replace the electrons after they have been excited by the photons of light. Place just 2 drops there, and then what we do is I move the clips back and forth, and then through capillary action, the electrolyte will spread throughout the cell. There we go. Okay, so we'll just clean up a little bit of the excess electrolyte on the slide here. We will go over and test it. The sensitized solar cell is set up for testing here on an overhead projector in a dark room because we want to have a controlled light source. So any photons of light coming from outside or from the windows would interfere with an accurate means of testing. And we use an overhead projector instead of actually using the sun, even though it's called a solar cell, because this is much more dependable and we can measure the light intensity. So the titanium dioxide nanostructure faces the light source, and that's coated in, or has been soaking in, the organic dyes. And electrons from the organic dyes are excited by the photons of light. They're carried by the titanium dioxide to the tin-coated slide. The tin-coated slide is conductive, where the electrons go through the negative, and we'll be able to read a voltage over here on our voltmeter. The counter electrode, with its carbon coating, acts as a catalyst, and the electrolyte, which is the iodide and triiodine, perform a redox reaction which renews the electrons to the system in a redox reaction. So that's in a nutshell how it works, and hopefully right now I'll turn on the overhead projector and we can see a voltage out of it. So are you ready?
Oh my gosh.
Okay, here we go, here we go.
Here's...
Okay. And look at that, just about half a volt from just this very small solar cell soaked in organic materials. Turn off the light, you can see immediately, once the photons are no longer exciting the electrons in the dye cell, that it drops very rapidly. And look, we're back down to millivolts. And it's been less than 30 seconds since I turned off the light source. And that is my project in a nutshell.